Hello everyone, welcome to my assignment on wireless communication network. So the topic of my assignment is Introduction to Wireless Sensor Networks and its application. So first of all, we will come to know about what is wireless sensor networks or introduction to wireless sensor networks. So wireless sensor networks can be defined as a self-configured wireless networks to monitor physical or environmental conditions such as temperature, sound, vibration, pressure, motion or pollutants, and to cooperatively pass their data through the network to a main sink where the data can be observed and analyzed. A sink or base station acts as an interface between users and the network. One can retrieve required information from the network by injecting queries and gathering information from the link. So next we come to the architecture of wireless sensor networks. Here we can see an user has been connected to internet, and the internet is being connected to a main sink, and through sink a number of nodes have been connected, and the data have is being collected through the target and being accommodated at the sink, and then it is being passed at the user. So this is the basic architecture of wireless sensor networks. So next, in continuation of the previous slides, we have these are the similar to wireless ad hoc networks in the sense that they rely on wireless connectivity and spontaneous formation of networks so that sensor data can be transported wirelessly. The wireless sensor network is built of nodes from a few to several hundred or even thousands, where each node is connected to one or sometimes several sensors. Each such sensor network has typically several parts: a radio transceiver with an internal antenna or connection to an external antenna, a microcontroller, an electronic circuit for interfacing with the sensors, and an energy source, usually a battery or an embedded form of energy harvesting. A sensor node might vary in size, and the cost of sensor nodes is similarly variable. Size and cost constraints on sensor nodes results in corresponding constraints on resources such as energy, memory, computational speed, and communications bandwidth. The topology of the wireless sensor networks can vary from a simple star network to an advanced multi-hop wireless network. The propagation technique between the hops and the network can be routing or flooding. So coming up with the characteristics of the wireless sensor networks, the main characteristics of the wireless sensor networks includes: number one, power consumption constraints for nodes using batteries and energy harvesting, ease of use, ability to withstand harsh environmental conditions, scalability to large scale of deployment, and ability to cope up with node failures. So now we will discuss the platforms where wireless sensor networks are used. So number one, we have hardware. One major challenge in a wireless sensor network is to produce low cost and tiny sensor nodes. There are an increasing number of small companies producing wireless sensor networks. Hardware and the commercial situation can be compared to home computing. Many of the nodes are still in research and the development stage, particularly their software. Also inherent to sensor networks adoption is the use of very low power methods for radio communications and data acquisition. In many applications, a wireless sensor network communicates with a local area network or a wide area network through a gateway. Here, by gateway, we mean that it acts as a bridge between the wireless sensor network and other network. This enables data to be stored and processed by devices with more resources, for example, in a remotely located server. Number two, we have wireless. There are several wireless standards and solutions for sensor node connectivity. Thread and Zigbee can connect sensors operating at 2.4 GHz at a data rate of 250 kilobits per second. Many use a low frequency to increase radio range, typically 1 kilometer. For example, Z Wave operates at 915 MHz, and in the EU, 868 MHz has been widely used, but these have a lower data rate, typically 50 kbps. kbps. So number third, we have software. Energy is the scarcest source of wireless sensor networks, and it determines the lifetime of wireless sensor networks. Wireless sensor network may be developed in large numbers in various environments, including remote and hostile regions where ad hoc communications are a key component. For these reasons, algorithms and protocols need to address the following issues: increased lifespan, robustness, and fault tolerance, self configuration. So, coming up with the last topic of our presentation, that is the application of wireless sensor networks. There are numerous applications in the wireless sensor networks, some of which are discussed below. Number one, we have area monitoring. Area monitoring is a common application of wireless sensor network. In area monitoring, the wireless sensor network is deployed over a region where some phenomenon is to be monitored. A military example is the use of sensors to detect enemy intrusion. Healthcare monitoring. There are several types of sensor networks for medical applications: implanted, wearable, and environment embedded. Implanted medical devices are those that are inserted inside a human body. Wearable devices are used on the body surface of a human or just as close proximity of the user. Environment embedded systems employ sensors contained in the environment. Environmental earth or earth sensing. There are many applications in monitoring environmental parameter, examples of which are given below. Air pollution monitoring. Wireless sensor networks have been deployed in several cities as Stockholm, London, and Brisbane to monitor the concentration of dangerous gases for citizens. Forest fire detection. A network of sensor nodes can be installed in a forest to detect where a fire has started. The nodes can be equipped with sensors to measure temperature, humidity, and the gases which are produced by fire in the trees or vegetation. Landslide detection. A landslide detection system makes use of wireless sensor network to detect the slight movement of soil and changes in various parameters that may occur before or during a landslide. Through the data gathered, it may be possible to know the impending occurrence of landslides long before it actually happens. So next we have water quality monitoring. Water quality monitoring involves analyzing water properties in dams, rivers, lakes, and oceans, as well as underground water reserves. The use of many wireless distributed sensors enables the creation of more accurate map of the water status and allows the permanent deployment of monitoring stations in locations of different access without the need of manual data retrieval. So next we have natural disaster prevention. Wireless sensor network can be effective in preventing adverse consequences of natural disasters like floods. Wireless nodes have been deployed successfully in rivers where changes in water levels must be monitored in real time. Industrial monitoring, we have machine health monitoring. Wireless sensor networks have been developed for machinery condition based maintenance (CBM) as they offer significant cost savings and enable new functionality. Wireless sensors can be placed in locations difficult or impossible to reach with a wired system such as rotating machinery and untethered vehicles. Data logging. Wireless sensor networks also are used for the collection of data for monitoring of environmental information. This can be as simple as the monitoring the temperature in a fridge or the level of water in overflow tanks in nuclear power plants. The statistical information can then be used to show how systems have been working. Water waste water monitoring. Monitoring the quality and level of water includes many activities such as checking the quality of underground or surface water and ensuring countries water infrastructure for the benefit of human and animal. It may be used to protect the wastage of water. Structural health monitoring. Wireless sensor network can be used to monitor the conditions of civil infrastructure and related geophysical process close to real time and over long periods through data logging using appropriately interfaced sensors. Wine production. Wireless sensor networks are used to monitor wine production both in field and the cellar. Threat detection. The wide area tracking system is a prototype network for detecting the ground-based nuclear devices such as nuclear briefcase bomb. WATS is being developed in the Lawrence Livermore National Laboratory. WATS would be made up of wireless gamma and neutron sensors connected through a communications network. Data picked up by the sensors undergo data fusion, which converts the information into easily interpreted forms. This data fusion is the most important aspects of the system. So these are the applications of wireless sensor network. I hope you like the video. So thank you.